I would like to thank first the organizers to give me an opportunity to present our results, which are really very simple results, to a larger audience. Normally, we speak mostly in academic circles like physics colloquium at universities, and of course those people understand well the physics, but of course it's important to have this also communicated to a larger audience if it should have any political effect. Now let me first say why I became interested in this subject at all. My background and my basically lifetime research and fun I had in my life was basically laser physics, so everything which has to do with lasers and playing with single atoms and whatever is, can be done by lasers and with lasers. In the 90s, I came across an article by one of the prominent global warming proponents, and this article just contained things which appeared to me contrary to real physics. And so there was, in the back of my head, was this feeling there's something fishy about this whole idea of CO2 and climate. And of course, I didn't have time until retirement, because if you have to look after 40 scientists and find €1 million a year to feed some of them, you have no time for such sort of esoteric question. But, well, my retirement gave me a chance and time to look more closely into this question, and I really had this feeling now I have time to see what the facts are really and what is fairy tales. Okay, so I have made myself familiar, let's say, for about a period of 2 years with the subject. It's not so different from what I did before, because we had a lot of signal analysis work in the laser physics anyway. So it is concerning the mathematical methods very closely related. And after 2 years, I got in contact with colleagues or with people who had different background but similar interest. And after 2 years, we started to do our own research. And so what we started with is given in this title here. We do spectral analysis of climate data. And this shows that all climate change in the last centuries is due to natural cycles, and there's no discernible effect of human activity. Now, here's mentioned the 3 people who worked on this. This is the person who does most of the numerical work. This is an astronomer from Hamburg. Well, he's from Heidelberg, an astronomer from Hamburg, and me. And so what have we done? Well, as the title said, we have done spectral analysis. I explain what that is to people who are not familiar with that. We have published these things, so it's reviewed by international reviewers. In this paper, 4 reviewers, and the next paper, we had 3 reviewers, and the next paper is not yet out. We have 2 reviewers. This, in fact, we did together with some colleagues in China who are interested in the subject. Well, what motivated our research was that what spectral analysis means is really the looking for cyclic behavior, for cycles in the temperature evolution. And surprisingly, for a research which has been funded globally by about $15 billion, we couldn't find a single paper which looked into the question of climate cycles. So we said, well, if there's no paper on that, we start doing that. And so we started doing that. What exactly do? We took the longest historical temperature records which are available. They are from stations in Central Europe, of course, because otherwise there was not much temperature documentation. And these go back almost to 1750. And so we have the longest records, and that gives us some material to look for cycles. Now, here's given the 6 stations which we found have the longest records in Germany, Paris, and so on. What you see among these different records is that initially the temperature was high. It dropped to around a minimum 1870 and then went up to today. This is the same for all stations. So we are allowed to do what you always do. If you do a global temperature, you average temperatures from individual stations. And if you do that, you come to this black curve, which gives the so to say a Central European temperature record. And just for comparison, that this is not just a Central European issue, we have plotted in blue temperatures from Antarctic ice cores, which were recently derived, and we see that basically also they have this minimum and go up. So we conclude that our stations in Central Europe are, representative for the whole global system. Recently, we have been able to prove that further. Okay, now we have these data, and now we look for cycles. We take what is called a spectrum, and it's mathematically obtained by so-called Fourier analysis or spectral analysis. And what we see here in this graph is several maxima. In spectral analysis, each of these maxima in such a spectrum corresponds to a cycle. So we see the evolution is really given by a lot of different cycles, and particularly this strong one. Now to explain why this is important, CO2 is definitely not cyclic, but is monotonically increasing in time. So we expected really from a spectrum like that, something which is flat like this red curve or this blue curve. But on the contrary, we see that all we get is cycles. And there's very little to see of any, let's say, monotonic increase, which would be caused by CO2. Now, to test that more precisely, we have just taken the opposite approach. We take the 6 strongest cycles. Maybe I should just give a time picture for people who are not so familiar with Fourier transform. So each of these maxima corresponds to such a cycle, and the whole climate evolution then is the sum of these cycles. So this is just, in principle, not quantitative, just to explain the mechanism. Okay, we have taken now the 6 strongest cycles which we find and retransformed them to the time domain, and the curve we get is the red curve, and the black curve is the measurements, a little bit smoothed by what you call running average to get rid of some noise. And what you see here is the 6 cycles which we choose, the strongest, are already representing the reality almost perfectly. And that means there is no trace from any influence of non-periodic things like industrial activity would be. You could think of CO2, you could think of heat generated by burning, but there's no such thing visible. All we have is the effect of cycles. Okay, now then the question is, of course, okay, we have these cycles. What is the cause of these cycles? What is the physical mechanism of these cycles? And, well, we had some indication of where that might come from. An interesting paper we found then is on solar activity. So this is spectrum of solar activity, spectrum in the same way as I showed before. So each peak gives a periodic variation. And you see very strong here a 208 period, 208-year period. And of course, that's very close to the period which we found 234 years in the temperature spectrum. So that gave us a clue of where roughly our strong period of more than 200 years is coming from. The authors of this paper, which appeared in the solar physics literature, not in the climate literature, nevertheless found that the relation between Earth temperature and solar activity is very close. And so they did basically the same as we did. They reconstructed the time variation of the solar activity by just adding the strongest cycles as we did. And what you get here is you find the minima, which corresponds to the historical, very well to the historical climate minima on Earth. You also get a prediction that from now on the temperature will fall. Okay, so that gave us a clue where this strong cycle, 200 plus years cycle, is coming from. It is related to solar activity. And of course, the mechanism is just what we heard in the first talk. It is the ionization of the solar wind, which is corresponding to the solar activity. Okay, now, as I said, maybe I should go backwards a little bit. As I said, we have data of the temperature measurements of 250 years, and we infer a cycle of about the same amount, of the same length, which is mathematically unsafe. So to make it clear, the cycle which comes out mathematically is an oscillation of this period. But we see in the data only one period, so that's not sufficient to know exactly if it's really periodic. This might be a one-off event. So we have to have temperature data which cover a longer time. So what we have done, we have taken proxy temperatures which are from tree rings, sediments, stalagmites, all kinds of things. There are two large collections of such data which create a temperature scale for the last 2,500 years, two different collections. And here's just given from where the geographical locations from where the data are coming. A large number comes actually from Austria, from tree rings. Okay, now this is where the proxies are coming from. Here we have a comparison of one of the temperature sets in blue with a periodic sine wave of 200 years. And you see, if you look at this picture closely, you see there's a very good correspondence. Every maximum corresponds to a maximum in the sine wave. Every minimum corresponds to a minimum in the sine wave. There's one exception, but overall we can have a good indication that for 2,500 years the Earth climate has had a periodic change of 250 years. And this is very well known in the solar literature. The solar literature, this period is called the Defries Cycle, after the person who discovered this long ago. And so now we have a good proof that our period, which we find from the limited data length of the historical temperature measurements, is really something which is real and not just an artifact of the mathematics, because now we have here a record of 2,500 years. Now here I have plotted the sine waves which are corresponding to the two different data sets in red and green, and I have superimposed the Antarctic temperature measurements, and you see very well that this fits quite well for the last couple of hundred years. Also, it agrees in the sense that from now on we have to wait for temperature minimum around 2070-80. Not at all temperature going up, as is always claimed in media, but in fact the temperature will go down. And I come back now to this curve. What we see here is, for one thing, the 200-year cycle, but we see also another cycle, which is exactly the cycle of 65 years, which was mentioned in the last talk. It is a very well-known terrestrial oscillation, has the name AMO-PDO. It's an oceanic oscillation. This modulates the overall temperature change by about plus minus 20%. Now, there's a few interesting things about this. At the moment, we have either, as mentioned, either stagnation of temperature or actually decrease of temperature on the Earth since 15 years. And in the literature, or among the climate scientists, there's a lot of discussion what is the reason for this decrease, while one would in fact expect an increase. And so there have been given 50 different reasons for that, most of them contradicting each other. In fact, now this is really very simple. It's trivial. It's the decrease here is nothing more than this oscillation of 65 years superimposed on the 200-year oscillation. And this particular steep increase, which is by climate catastrophists always cited as proof of CO2 influence, of increasing CO2, increasing the temperature, is also nothing more than the superposition of these two cycles, of the increasing slope of the 200-year cycle with the increasing slope of the 65-year cycle. So basically everything we have here is very easily explained by just two cycles. Okay, now I just recently found some work which confirms our results by completely different methods. Here's given the CRU temperature scale in red. It starts only here because the official statements try to avoid the insight that temperature was dropping from 1800 to 1870, so they always start around 1870. Okay, you see this 200-year cycle superimposed with the 65-year cycle gives exactly the world temperature history, and it's exactly the same result we have, but obtained by a completely different method. Okay, this is just to give you a picture again about this is measured data. We are at the moment here. This is official predictions, and of course in reality it will go like this. So we expect this next minimum really at 2035, so we will be living at that time, so we will experience that at that time. Yeah, what I wanted to give, but I have not time for that, there are many papers which give a clear indication that CO2 cannot play a role among others. This paper, there are, even if you go and do very simple numbers, you find that the official statements are contradictory. I wanted to give a little bit of this, but well, I have data here on sea level change and everything, and everywhere, let's say, CO2 turns out not to play a role, except for food production, as we have heard. Now, these are the conclusions of my talk. Climate change during the recent centuries is periodic. Warming since 1870, which is always attributed to CO2, is in reality caused by the roughly 200-year solar Defries cycle, which is a well-known cycle for the sun, known. And the present cooling and increased warming of 1970 to 1997 is due essentially to the 65-year period cycle we heard in the last talk. And measurements show no trace of warming by CO2. All change is natural. So thanks for giving me the time, and thanks for the audience.